The remainder theorem is used to find the remainder when a polynomial is divided by a linear polynomial. My name is Kyle Lawrence B. Solteo from grade 10 Saints Benedict and Scholastica, and today I am going to show you how to evaluate and find the remainder using the remainder theorem. If a polynomial p of x is divided by x minus k, where k is a real number, then the remainder is the value of p of k. So that means if we have a polynomial p of x being divided by x minus k, get the remainder by evaluating the p of x to the value of k. This will be the result after evaluating it. Let us find the remainder of these polynomials in order for us to understand it more. We can use both the long division and synthetic division to find the quotient. However, we only need to find the remainder, and so we are going to use the polynomial remainder theorem or substitution method here, since it is much faster and easier, and it works just like this.
First, we're gonna let p of x equals to 4x to the power of 100 plus 34x cubed minus 1. To get the remainder, we must evaluate the p of x at x plus 1. Evaluate it by x plus 1 equals to 0. Next, we're gonna transpose the positive 1 to the right side. Since it is a positive sign, it will become negative when we are transposing. Now x is equal to negative 1. Now we're going to substitute the x by negative 1 in the equation. And after substituting the x by negative 1, we're going to equate it now.
The remainder when 4x to the power of 100 plus 34x cubed minus is divided by x plus 1 is negative 31. Now for another example, we'll use the synthetic division to find the remainder.
First, we're gonna equate x minus 1 equals to 0. We're gonna transpose the negative 1 to the right side. Since it is a negative sign, it will turn into a positive sign upon transposing it. Next, we're gonna place it in the box directly to the left of the list of coefficients and constants. Make sure that it is written in standard form, which means that the exponents are in decreasing order. Our coefficients and constant here are 2, 3, negative 5, and 7. Now we're gonna write down the coefficients and constant of the polynomial right beside the box. Don't forget to include zeros for the missing terms of the polynomial. Since the cube term is missing, I wrote the 0 in its place. Now draw a horizontal line just like this. Next step is bring down the first coefficient below the horizontal line. We're gonna multiply that by the number in the box. Place the product under the next coefficient in the list, and then add the column of constants and place the sum below the horizontal line. Repeat the process of multiplying the number below the horizontal with the number in the box and adding the column of constants until such time you reach the last column. The last number in the bottom row is the remainder.
So the remainder using the synthetic division is found to be equal to 7. Now for the last example, we'll use the long division to find the remainder.
Let's prepare the long division first. Write the divisor and the dividend. Arrange the terms in the decreasing order of their indices and write the missing terms with 0 as their coefficient. For the first term of the quotient, divide the first term of the dividend by the first term of the divisor. Multiply this term of the quotient by the divisor to get the product. Subtract this product from the dividend and bring down the next term if there's any. The difference and the brought down term will form the new dividend. Follow this process until you get a remainder, which can be a 0 or a lower index than the divisor.
So the remainder using long division is found to be equal to 0, meaning there is no remainder. The remainder theorem has some limitations and works only when the divisor is linear. That will be all. I hope my explanations are clear and understandable. Thank you so much for listening.